Okay, everybody, so we're going to keep going on in our work with Bruce here. So we're picking up from around 1713 here in Bruce. And 1713 covers the reaction of two esters, and this actually gets its own name. It's a Claisen condensation. All right, so it's not that different from what we'd expect to see with two aldehydes or two ketones or mixtures of aldehydes and ketones. Now let's just throw esters into the mix because we have another thing. So we have two identical esters here, and we're going to react them in the presence of this base and then an acid. So first reaction, second reaction. One thing I want you to notice is that this base is sort of the analog of this part of the ester that we're working with. Okay, that is by design. So this molecule right here is sort of what we're starting with here. All of this here. This oxygen is going to end up abstracting one of these hydrogens, the alpha. Okay, and so this carbon is the same as this one. This CH3 is there. It's also untouched. And what it's going to do is it's going to attach here at this carbonyl. This will end up being kicked off. It still has a CH2 and a CH3 attached to it, and we reform the carbonyl. So we get this kind of compound. So what we end up making is a beta diketo ester. So beta because it's on the beta carbon, so we make a beta diketo ester. Okay, a very exotic sounding ingredient or something. Let's look at the mechanism for it. It's not too bad. So this oxygen right here in the base ends up grabbing onto this hydrogen, kicking these electrons up to here. So we end up making this species here, and we have, HOCH3 formed here as a result. This is a rather strong base, so it's going to end up grabbing onto one of these hydrogens right here. No, it's not. I was wrong. My mistake. Ignore that. It ends up going to here. So this part of this molecule is this part right here. So all of this stuff is this stuff. This stuff is this stuff. Okay. So this here ends up attaching to this. Now these electrons get kicked up here. So that now has a negative charge. We have an OCH3 down here, and then everything else that was attached to it. So CH2 and R. Okay? Now, these electrons are going to end up kicking back down, which will end up kicking this off. This is the most stable thing that can end up leaving. So all of this part of the molecule stays the same as it was. And what we end up forming is a new carbonyl double bond, OCH3 minus ends up coming off, and then CH2R is what's still attached to that. We acidify after that, and then everything else here is pretty much done. So we remove the alpha carbon, the enolate adds to the carbonyl, and the carbonyl reforms. So that's kind of how that works. Now, if you want to compare it to the Claisen condensation and the Aldol addition, in terms of the reagents, which is what we're looking at here. Here we've got two esters, or we have aldehydes and ketones, so they're pretty similar there. In terms of the intermediate that's formed, here we have a tetrahedral intermediate where we've got an oxygen with a negative charge and an OR on it, and here we have a carbon with an oxygen with a negative charge here. So the difference is that this has something to kick off, and this does not. So that when these electrons come back down, this gets kicked off and we get a carbonyl. Okay, so this is our product. And here we're able to grab an H from somewhere and we make an alcohol. So here we form an alcohol and here we form a ketone. And that's the main difference between the Claisen condensation and Aldol additions. Here we're going to form a carbonyl compound and here we form an alcohol. So let's take a look and see. This is problem 30A out of Bruce. So basically, we've got this base right here. And what that'll end up doing is there are no alpha carbons here on this one. So this is going to abstract this hydrogen here. And then once the once it's got its negative charge, this acts like a nucleophile, and it's going to end up adding here at this one. So this part of this molecule, and I'll sort of like draw dashes around it, is this. Okay, so what we end up forming is we have our CH, let's see, one of those H's gets away, so it's just CH, CH3. It forms a bond with this carbon, and then it reforms its double bond, and one of these gets kicked off. So O, CH2, CH3. And if I was to write that a little more neatly, just to be neat, it's CH3, CH2, O, like that, CH, CH3, O, CH2, CH3. So these two guys here are identical, so maybe you want to give that a shot and see if you can agree. So I hope that helps with this portion of it. Again, we have like lots of different things we can combine. So yeah, we will continue working on this. But knowing the difference between Claisen condensations and aldol additions, don't forget that esters are the thing we're looking at here. All right, good luck.